In this section, we're going to graph using x and y intercepts, and also the slope-intercept form. So when you're doing these problems, you'll see that there's two coordinate planes, and you're going to end up graphing the same line. So it should be the same line, but with two different methods. So here's an example. Number 29. We have this equation, and I'm asked to graph using the x and y intercepts. So when I do that, I want to isolate the constant. I like to get the x and the y term all on one side of the equals sign. So go ahead and do that. I'll subtract that 3x from both sides. What I'm left with is a y minus 3x equals negative 2. So I just brought down the negative 2 and I rewrote the equation. Now I'm ready to solve for the x-intercept and the y-intercept. So remember, the x-intercept, you're going to end up setting y equal to 0. And for the y-intercept, we're going to do the opposite. We're going to set, this time, x equal to 0. And so when we do that, here's what we've got. The x-intercept, the y term cancels, so I'm just left with negative 3x equals negative 2. On the y-intercept part, again, I'm solving for y. I want to set x equal to 0. So this term cancels out, and we've got our point. Y equals negative 2. So for the x-intercept, I have one step further I have to go. I have to divide by negative 3. And when I do that, I'm left with an x equals 2/3. Now that's a fraction. So this is where the x and y intercept can be kind of tough, because I have to graph a fraction of a point. And so my x-intercept is an ordered pair, 2, 3, 0. 2/3, 0. And the y-intercept, again, that's a different point. When x is 0, y is negative 2. So I go over to those points. Y at negative 2 is down 2 spaces. That's easy. But 2/3, well, that doesn't quite make it to 1. It makes it just a little bit past 1/2, not quite 3/4. So now I've got those 2 points. I can draw a line between those. And that would be our answer. So again, knowing that those intercepts are at those 2 points. And I think what I'll do, I'll go ahead and highlight those in a different color so you can see where those were. Well, we're going to do the same thing, graph the same line. It's going to look exactly the same, but this time we're going to use the slope-intercept form. And the slope-intercept form gives us one of those intercepts. It's the y-intercept it gives us. And the reason is that you're going to set x equal to 0, and we're just left with y equals negative 2. So that is our y-intercept. From there, the number out in front of x, that's our slope. So the slope, m, is 3. Now I'm going to treat 3 as a fraction, 3/1. And remember that 3 on top tells us what to do in the y direction. So that's going to tell me to go up 3 spaces. The denominator, so that's what the 3 tells me to do. The 1, that tells me to go to the right, because they're both positive. So we're going in the positive y direction, which is up, and the positive x direction, which is to the right. But we could also do something different. We could have gone a different way. See, if we rewrite this as negative 3 over negative 1, that would give us the same slope, because the two negatives would cancel to make a positive. And if that's the case, the negative 3 would tell me to go down. So I'd have to go down 3 spaces. And here, this negative 1 would tell me to go left 1 space. So let's go ahead and try graphing this. We always have to start with a starting point. And our starting point in this case is negative 2. So I'm going to go down 2 spaces on the y-axis. We'll put a dot there. That's the same y-intercept I have here. And it should be, because again, these are the same lines. So from there, I'm going to use the slope. And I'll do the positive one first. So I'm going up 3 spaces from this blue point, from the y-intercept, up 3/1. I do that again, up 3/1. Up 3 spaces over 1. And I can also go the other way. So that's what this is for, is to be able to go both ways so you can extend your line. So down 3 spaces over 1 to the left. and then from there I run out of room. So now I'm ready to go ahead and graph or draw the line between the points. So go ahead and draw that line and put arrows at the end showing that it goes on forever in those directions. Well, that's it. So it's the same line. The only difference is I drew one a little bit longer than the other because I had more points. And from there, we can see that the slope-intercept form is sometimes going to end up being easier depending on the type of equation we have. This one was already set up for us in the slope-intercept form. Well, let's take a look at this next one here. Here we've got 1/2 y minus x equals 2. So I'll start with the x-intercept and the y-intercept form first. So I'll write down x-intercept, and remember we set y equal to 0. And then for the y-intercept, I'm going to end up setting x equal to 0. Now this is all set up for the x-y-intercept method because y and x are on the same side. So let's take a look at setting y equal to 0. This term will cancel out, so all I'm left with is negative x equals 2. So to cancel out that negative sign, I'm going to either multiply or divide by a negative. Either way, it'll still do the same work. It'll cancel out the negative sign in front of x. So what I've got left? Well, I've got this x equals negative 2. And from there, I can go ahead and find my y-intercept. Now again, when you find the y-intercept, this negative x is gone. So what I've got left? I've got a 1/2 y equals 2. So to solve, all I'm going to do is multiply by the reciprocal. So the reciprocal is just 2 over 1. So I do that on both sides, multiply by 2 on this side. Those 2's will cancel out. So all I'm left with is just y equals 4. So now we've got it. We've got our 2 points. Now again, this is a separate ordered pair. It's negative 2, 0, because when y is 0, x is negative 2. On this side, when x is 0, y is 4. So we can go ahead and plot those 2 points on our coordinate plane. So I'll do the x-intercept first, go 2 spaces to the left, and then put a dot there. And then for the y-intercept, I'm going 4 spaces up. Put a dot there. Now I've got my 2 intercepts, and I can go ahead and draw a line between those 2 points. So that's the xy intercept method. Works really good when x and y are on the same side, and also works better when we don't have to have a fraction of a point, or at least when the points are far enough apart so it's easy to figure out where that line is going. Let's take a look at the other method here, the slope-intercept form. In order to use this, I've got to get this y by itself. So I've got some extra work I got to do here. I've got to first move this x back to the other side. I need to add it to both sides. So once I do that, rewrite what's left over. Still have this 1/2 y, and this equals x plus 2. So from there, I just have one step. Just got to get rid of that 1/2. Now this is where you multiply by the reciprocal. But remember, if you multiply by the reciprocal here, I'm going to multiply every number, the x and the 2, by that 2. So when I do that, here's what I've got. I've got a y equals 2x plus 4. So when I go ahead and graph this, I've got my y-intercept, that's this number here, y-intercept, that's what I'll graph first, and then I've got this other number, this 2, and this is my slope. So remember, I write that as a fraction, 2 over 1. It tells me what to do in the y direction, what to do in the x. So we'll start at that y-intercept, positive 4. Put the dot there, and then use the slope. So remember, the slope is 2 to 1. So I'm going to go up 2 spaces from this y-intercept, and then over 1. Do that again, up 2 over 1. I could also go the other direction. I could go down 2, and then 1 to the left. Down 2, 1 to the left. And you could do that a bunch of times, because I don't run out of room that way until way down here. So from there, I can go ahead and draw the line. So you can see that when you have these problems, you have more points with this slope-intercept form because you can use that slope to find any number of points. So that's nice to be able to draw a nice line through all those points. Anyhow, we'll go ahead and put some arrows at the end to show that those lines go on forever. But you can see they're the same lines, just two different methods to solve. So part 3 is going to deal with the domain and range, and also whether a relation is a function.